Welcome back. Can't believe you. It's been so long since I've talked to you on this stupid thing. But it's alright. We all know how fun this year has been. Alright, so today our lesson is on quartiles. It has the root word quart, which is like a quarter. So we're splitting things up into four. So a quartile is when we're dividing an ordered set, and that word ordered is important right there. It means the numbers must be in order. We're dividing it into four equal groups. And the dividing points are what are called the quartiles. So you can see quartile 1 is right here, right at the dividing point between the first 25% and the second 25%. And then quartile 2, which has a special name called median, it's the middle, that's the exact center number. And then quartile 3 is essentially the middle of the second half of the list. Right, then we have what's called interquartile range. That is the difference between quartile 1 and quartile 3. So essentially we're going to be subtracting those. That's what difference means, the subtraction. So take quartile 3 minus quartile 1 and we'll find the interquartile range. Inter meaning center, the middle 50%. And we also have outliers. Outlier is a number that doesn't fit with the rest of the number set. And there can be more than one of these, but it starts getting to be too many of them, then they're not really outliers. So usually maybe one on the low end and one on the high end at most, but usually just one or none. It's possible that the list has no outliers. And again, an outlier has a specific definition we'll learn more in a stats chapter later in the year. But for now, it's just whatever one looks like it seems to be out of place with the rest of the set. All right, so let's try an example. All right, so first thing I would need to do this problem is I need to put these numbers in order. It's a little bit annoying, so I'm trying to give you a strategy. I look for the smallest number 4, and there were 2 of them. So I mark them off and rewrite them. Then I'm looking for any 5s, don't see any. Then 6s, there's 1 6. And then 7s, there's 1 2 7s. And then 8s, 1 2 3 8s. And then 9s, I see a 9 there. And then 10s, there's 1 2 3 10s. If you're wondering where I got these numbers, these are a number of in-person students I have each period of each day. So for example, that's period 1. I have 9 group 1 students in person and 4 group 2 students in person. There's period 2 and period 3, and for me period 5, I don't have a period 4, and then period 6, and then period 7. So that's where I got these particular numbers. So I'm trying to look at some actual real data here. So there's my number set. All right, now the first thing I want to do, the easiest thing, and I listed it first, is to find the median. Also sometimes called quartile 2, but hardly ever. It's just called the median. So I want to find the exact middle number. So a couple of options. I could just kind of mark one off from the left and one off from the right, and then one off from the left and one off from the right, one from the left, one from the right, one from the left, one from the right, one from the left, one from the right, until I get to those 2 in the center here, 2 numbers that share the middle. And we learned last time when there's 2 numbers that share the middle, we add them and divide by 2. So our median is going to be 8. But again, we had those 2 numbers that shared the middle. Another way to do it is to count the numbers in the list. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right? So if you take 12 and you add 1 and then divide by 2, I think is how it works. You take the number of things in the set and you add 1 and divide by 2. It'll tell you which number is the middle. So if I take 12 and add 1, that's 13, divided by 2, that's 6.5. So 1, 2, 3, 4, 5, 6.5. That means right in between numbers 6 and 8. And again, that would be right there. So that's a mathematical way, but most of the time we just kind of count, work our way back in. But again, we had 2 numbers that shared the middle. All right? And then we added them, divided by 2. Now we want to go ahead and find the quartile 1 number. Essentially, quartile 1 is to find the median of the first half of the list, not counting any numbers that are part of the median. So since we had 2 numbers that shared the median, I am going to essentially now be finding the median of that first half of numbers. That's quartile 1. A little easier to see. There's only 5 numbers there. The middle one is 6, so that's our quartile 1 number. Quartile 3 is to do the same thing with the back half of the list. Anything that wasn't part of the median, and then find the middle number. Again, a little easier since the list is smaller. That would be a 10. All right, now the interquartile range is to take those two numbers I just found, Q1 and Q3, and minus them. 10 minus 6 equals 4. There's our interquartile range. And then outlier, any number that doesn't seem to fit in the list. So I'm looking at the low end, the two 4s at the end, so that seems to fit right in. Those numbers don't seem too small. And on the right side, I see a bunch of 10s. Those seem to fit right in. So I would say that there are no outliers in this particular problem because there are no numbers that seem to be out of place. Now, if there would have been another number in the back like 312, well, that number clearly would be out of place and not fit. That's what an outlier is. Just a number that doesn't seem to match the rest of the list of numbers. All right, so this is your work today. Is again just putting them in order, kind of finding middles. Again, you find the middle, then you find the middle of each half, and you don't count the ones you used when you were finding the mean. So again, those two 8s in the middle, I did not reuse them when finding quartile 1 and quartile 3. All right. If you need any help, join me on the Zoom and we can do one of these together or two of them together, whatever it needs. All right, good luck today.